Today we're going to talk about polynomials. So if we were to have some x tiles and we have 4 negative x tiles, and then we're going to add 7 unit tiles. Lastly, we can add 3 x squared tiles. If we circle the like terms or the shapes that are alike, we will find the monomials that are in this particular polynomial expression. For instance, here we have negative 4x, which is a monomial or term. We have plus 7, another monomial, and then plus 3x squared. If we would like to find the standard form, we need to move it such that the term that has the highest degree or exponent, in this case 2, will be the leading term. If we were going to add 2 separate polynomials to one another, we could start on the left with the polynomial 3x squared minus 2x plus 1. Next, on our other polynomial, we could have x squared minus 3. If we decide to add the 2 polynomials together, we simply combine them onto one mat. So we can move all of the tiles from the right over to the left. Before we decide that we're finished, we might look for opposite pairs. 1 plus negative 1 is 0. So we're left with 4x squared minus 2x minus 2. The way to do this addition in a horizontal fashion is to remove the parentheses from both polynomials and look for like terms. 3x squared plus x squared is 4x squared, minus 2x, and 1 minus 3 is negative 2. We can also add these polynomials in vertical format. We need to be sure and line up the like terms much like we would line up place values if we were doing numbers. And we can fill in a place value with 0 times x. So now we simply add all of the terms that are alike in a vertical fashion, and we get 4x squared minus 2x minus 2. To subtract, we're going to start off in much the same fashion with the same 2 polynomials that we started with in our addition problem. Now we're going to find the difference. When we subtract, it's the same as adding the opposites of everything in the second polynomial. So I can turn this into an addition problem by taking the opposites of the negative 3's, which are positive 3's, and the opposite of x squared, which is negative x squared, and now combining them on the same mat. After I do that, I find a 0 pair with x squared minus x squared, and I have the difference 2x squared minus 2x plus 4. This problem can be done in a horizontal fashion. Parentheses are an absolute must because the parentheses denote that I have 2 separate polynomials that I'm subtracting from each other. The second polynomial is being subtracted, which is very much like distributing a negative 1. So if I remove parentheses, I get 3x squared minus 2x plus 1 minus x squared plus 3. Combining like terms, I get 2x squared minus 2x plus 4 as my sum. Again, this problem can also be done vertically. So I set up my first polynomial on the top row. I'm going to subtract the second polynomial, lining up the place values or the like terms. And once again, if I'm going to be adding, subtracting, I can change it to an addition problem if I change the signs of everything in the second polynomial. So this becomes addition when I change x squared to negative x squared and 3 to negative 3 to plus 3. And I get, once again, 2x squared minus 2x plus 4.